today I will discuss the January 2020 Further Pure Mathematics Paper 1. Question number 1. Determine the values of the constant P for which A is singular. So what do you mean by a singular matrix? In a singular matrix, you know the determinant will be equal to 0. Okay, so we need to get the determinant of A. How do we calculate the determinant? Take the product of the main diagonal, right? So the main diagonal is so this one. P and P plus 3. So multiply P into P plus 3, main diagonal products, subtract with the product of the other diagonal. Minus 2 into minus 5 is plus 10. Okay. So then we'll get the answer here. P square plus 3P plus into minus, that is minus 10. So this is the determinant of A. To be singular, determinant of A must be set to 0. Are you with me? Okay, so then this is the quadratic equation. Can I know the values here? P minus 2, P plus 5 when you factorize. So this gives me P equals to 2, or you can write the thing properly. So here P minus 2 is equal to 0, or P plus 5 is equal to 0, which gives us P equals to 2 or P equals to minus 5. Is this clear? And then they tell you, given that P equals 3, determine A inverse. Okay, so if P equals 3, you realize it's not one of these two P values, which means if P equals 3, it is non-singular, isn't it? So, you know, for singular matrices, the inverse matrix doesn't exist. So for P value 2 or P value minus 5, you will not have an inverse matrix. But when P equals 3, that's a different value. So we can calculate the inverse. Okay, let's get the inverse matrix, part B. So when P equals to 3, let's get the determinant of A first. So determinant A is equal to P square plus 3P minus 10, right? Input the P value as 3 square plus 3 into 3 minus 10. Can I know the answer? 9 plus 9 minus 10. So 18 minus 10 is 8. Determinant of A is 8. And then you also need to get the matrix A. Matrix A is P is 3, minus 2, minus 5. P plus 3 is 3 plus 3, which is 6. Okay, so time to get A inverse. A inverse equals to 1 over determinant A. And then how about the matrix? In the main diagonal, the elements are switched. In the main diagonal, you switch the elements. In the other diagonal, you only change the signs. So both of them are negative. So that means they'll both be positive. So 1 over determinant A is 1 over 8. 6, 2, 5, 3. Okay, is this clear? So you could input the 8 inside and write this as 6 over 8, which is 3 over 4, 5 over 8, 1 over 4, 3 over. It's not actually necessary. You could go to this step and keep as a final answer, or you could keep it in this step. This could be a final answer, or this. So any of them are okay. You could keep them in exact decimals. So all of those are equivalent correct answers. Okay. Okay, moving to question number 2. Given that x equal minus 1 over 3 is the root of the equation 3x cubed plus kx square plus 33x plus 13 equals 0, determine the value of k. Okay, how do we determine the value of k? So if x equals minus 1 over 3 is a root, what do we have to say here? Yeah. What do we say here? So this is your fx equation, right? So you set fx is 3x cubed plus kx square plus 33x plus 13, and you set it to 0. So they say you x equals minus 1 over 3 is a root. So if x equals minus 1 over 3 is a root, what happens? When you replace your x value as minus 1 over 3, or we say f of minus 1 over 3 must be equal to 0. Isn't it? Replace the value. So replace the x values with minus 1 over 3, because minus 1 over 3 is the root. 3 into minus 1 over 3 cube plus k into minus 1 over 3 square plus 33 into minus 1 over 3 plus 13 equals 0. Do you agree with me? Simplify. How do we get here? So you set it equal to 0 because at x equals minus 1 over 3, it's a root. A root means you make it equal to 0. Okay, what do we get here? 3 into minus 1 over 27. This is k into minus 1 over 3 square is positive 1 over 9. Make sure you type the powers are typed outside of the bracket when you're typing in the calculator, okay? The powers, this is minus 11 plus 13 equals 0. So k into 1 over 9, if you keep it, make it the subject, take all the other terms to the other side, minus 11 goes as plus 11, plus 13 goes as minus 13. This is minus 1 over 9, right? Shall I immediately write as minus 1 over 9 here? Minus 1 over 9 comes to the other side as plus 1 over 9. Can I know the value here? K into 1 over 9 equals how much? Minus 17 over 9. Therefore, when k equals, you take the 9 to the other side as a multiplication. Minus 17 over 9 into 9 gives you k is equal to minus 17. Is this clear? Okay, then they ask you in part B, determine the other two roots of the equation in the form a plus ib, and where a and b are real numbers. Okay, how do we get the other two roots? So first we have here our fx equation equals 3x cubed plus what is our k value? Minus 17. So shall I write here minus 17x square? 3x cubed minus 17x square plus 33x plus 13 equals 0. Do you agree with me? Okay, so now this is our equation, and we know one root of this cubic equation is, okay, one root of this cubic equation is x equals minus 1 over 3, which means what is the factor? If you have here x equals minus 1 over 3 as the root, do you know, I mean, we don't write the root as x plus 1 over 3. No, that's not how we do it. How do we fix it? How do we get the factor? Take first the 3 to the other side. Then you get 3x equals minus 1, which gives you the factor as what? 3x plus 1. The factor is 3x plus 1, right? So then now you know it's a cubic equation, and you're supposed to have, you're supposed to be, we normally expect to see 3 factors. But then out of the 3, one factor is 3x plus 1, right? So the other remaining factor should be a what type of factor? It's a quadratic factor. Do you agree? Should be something of the form ax square plus bx plus c. Do you agree? It must be of the form ax square plus bx plus c, because the other remaining part is a quadratic term. Okay, so now there are two ways to get this quadratic term. What are the two ways? One way is that you could actually take your fx and divide by 3x plus 1, do long division. Do P2 long division, and you can immediately get the quadratic factor for the quotient of your long division. Okay, or else, yeah, so what can we do here? The other method we can do here is we can compare coefficients. We could compare coefficients. So how does that work? How does that work? So for example, x cube. Take the easiest ones. How do I compare x cube coefficient? Here we have 3x cube. That's the only x cube coefficient. How do I get x cube on this side? You can see 3x into ax square is 3ax cube. Do I get x cube by multiplying any other term here? No, we can't get x cube with any other term. X cube can only be made by multiplying an x term with the x square. So that's only available in one option. So 3x into ax square is 3ax cube. So coefficient is 3a, which tells you a value is equal to 1. So a equals 1. Okay, and then the next one. Shall we compare the coefficient for the constant? It's a lot easier. Or else we can go for the x square. Okay, we'll go for x square. We'll go in order. So when you go with x square, what do you have for the x square coefficient here? Minus 17 on the left side equals to x square coefficient 3x into bx. First of all, 3x into bx is 3bx square. Okay, and then 3x into c is, I don't get x square. 1 into ax square is ax square. So plus 1 ax square. Do I get any other x square coefficients here? No. So I get here minus 17 equals 3b, a is 1. So 3b equals to minus 17. The plus 1 comes as minus 1. 3b equals to minus 18. Which means b is equal to minus 6. And then now I only have to find the c value. Better to go with the constant rather than going with x. Compare coefficient for the constant. So what do we have on this side for the constant? 13 equals to, on the other side, what do we have for the constant? So all the terms that do not give any x terms, what is it? 3x will not, we can't take anyway 3x, there's already x. The only one that will not give any x term is 1 into c. So c is directly 13. Can you understand? So then I got the quadratic factor. So that means my fx is equal to 3x plus 1 times ax square. A is 1, b is minus 6x, c is plus 13. Okay, so this is the quadratic factor. Then they ask you to find the other two roots of this equation in the form a plus ib. So the other two roots, we have to solve the quadratic equation. X square minus 6x plus 13 equals 0, right? Okay, so how do we solve? You could either complete the square or you could use the quadratic formula. So I'll complete the square. X minus, when you complete the square, you have to take half of 6 here, which is 3 square, compulsory minus, and write the square of minus 3 here, which is 9, plus 9. Okay, so this is a compulsory minus. X minus half of the value is 6 here, 3 square, a compulsory minus, and just the square of the 3, 9. That takes care of these two. Then plus 13 equals to 0. That gives me x minus 3 square equals minus 9 plus 13 is plus 4. Now we have to solve and make x the subject. So x minus 3 square equals minus 4, which gives me x minus 3. When you square, to remove the square, we put root and put plus or minus. So x minus 3 equals to plus or minus 2y. So x minus 3 equals to plus 2y. Or x minus 3 equals to minus 2y. X equals plus 3 plus 2y, or x equals 3 minus 2y. Okay, so these are the two roots. This is what they wanted you to find, right? Find the other two roots in the form a plus ib, where a and b are real numbers. So these are the other two roots. Is this clear? Question number 3. Use the standard results for summation of r square and summation of r cube from 1 to n to show that for all positive integers n, the summation of r square 2r plus 3 is equal to this particular show that. Okay, so this is a show that. So make sure you show all the relevant workings. So what are the extra things we need here? What are the standard results for summation of r square? Summation of r square, the standard result that you must use is equal, what is the equation? 1 over 6 n plus 1, 2n plus 1. Summation of r cube for r equals 1 to n. The answer is 1 over 4 n square n plus 1 square. Also, you may need the summation of 1 from 1 to n. Summation of 1 from 1 to n is n. So these are some extra things that you may need. Okay. Yes, so summation of 1 means when this is r to the power 0, isn't it? Okay, so if you add 1 n times, you get n. Okay, just I wrote it as extra rule because it's a general rule that we use. Anyway, they have told us to mainly use these two. Okay, so let's get it done. Part A. Part A. So we need to get the summation from 1 to n. The summation of r square times 2r plus 3. Okay, so how does that work? Let's open the bracket. Summation of r square 2r plus 3. When you open the bracket, you get r square into 2r is 2r cube plus 3r square. Okay, so then summation of, I'll open the bracket. I'll bring the 2 out. 2 times summation r cube plus 3 times summation r square. Okay, so directly we had to use the two rules that we just derived, that we just wrote down. Okay, so summation of r square is 2 times 1 over 6 n plus 1 2 sorry, 1 over 6, n plus 1, 2n plus 1. Yes. n plus 1, 2n plus 1. Then plus 3 times summation of r square is, sorry, this is summation of r cube. This is summation of r square. So this needs to interchange. Summation of r cube is 1 over 4 n square. N plus 1 square plus 3 times this is 1 over 6 n plus 1 2n plus 1. Okay. So now we have to simplify this and get this show that. So what is the best way to get the show that? Are you going to actually expand the entire thing? Definitely don't do that, right? So we will take the common thing out. So here we can cut 2 and 4. And this is half n square n plus 1 square. 3 and 6 and you cut, it's half n plus 1 2n plus 1. Do not expand the bracket because that will waste a lot of time. Take the common thing out. Now you can see in the show that half is taken out, the n is taken out, there's n plus 1. So you can see here half is common to both. What else is common? N is common. We can take a single n and we can also take a single n plus 1. A single n plus 1 can be taken out, right? Okay, so then let's create this. When I take half n plus 1 out, what's remaining? n plus 1 plus here half n plus 1 goes, you are remaining with 2n plus 1. Can you see this is the easiest way to simplify to get your answer. So half n plus 1 and inside the bracket you get n square plus n into 1 is n, 2n plus 1. So this will give us a show that half n plus 1 n square plus 3n plus 1. Is this clear? So this is the show that for 4 marks. Then part B, they say, hence calculate the value of summation of r square to r plus 3 from 10 to 25. Okay, so how do we get the summation of this person from 10 to 25? Okay, yeah, so we write the equation here. You do realize in part B. Okay, so we have, if you want the summation of f of r from r equals a to n, what is the rule? We take the summation. The thing is, we know to use these rules. The summation of r square to r plus 3, we know to use, we can only use this particular result only if you start from r equals 1. If you start from another random value, can we use this result? No, so it needs to start from 1. So here they want the summation from 10 to 25, not from 1 to 25. If it was 1 to 25, all we had to do is just replace the n with 25. But here it's 10 to 25, so the starting value is not 1. So how do we fix this? There's a special rule in that we learn. If they give summation of some f of r from a to n, where the a is not 1, then how does it work? We take the summation from 1 to n, the total, the sum of all the terms, and we subtract the summation from where to where? From 1 to a minus 1, 1 below this. Are you with me? So that is the exact rule that we are going to use here. Okay, so in part B, I will do it over here. So just reminding you the rule here, r equals 10 to 25, r square times 2r plus 3. So how do we expand this? This is the summation of r from 1 to 25. Are you with me? R square 2r plus 3 summation from 1 to 25. I should subtract with what? The summation of r square 2r plus 3, right? R square 2r plus 3 from where to where? From 1 to, in this case, this should be from 1 to 9 because it's 10 over here. So now we can immediately input our result because we have the summation of r square 2r plus 3 from 1 to n. Replace the first one, n with 25. Tell me, how does it work? Replace the n's with 25 here. Yes? 25 over 2, 25 plus 1, that is 26 into 25 square plus 3 times 25 plus 1. Okay, and then that should be subtracted with, tell me, yeah? 9 over 2, 9 plus 1 is 10 into 9 square plus 3 times 9 plus 1. Am I correct? I replaced all the n values with 9. Okay? 9 square, correct, right? Plus 3 times 9, all the n should be replaced. Plus 1. Now, It's a matter of typing this entire expression in the calculator and getting your answer. Can I know the answer for this section first? 227825. Can I know the answer for the other one? 4905. Okay. Now subtract and tell me the final answer. 222920. So this is the summation of r square 2r plus 3 from the 10th term to the 25th term. Okay, is this clear? Question number 4, they give you z1 equal p plus 5y, z2 equal 9 plus 8i, and z3 equal z1 over z2, where p is a real constant. So these are complex numbers, right? Determine z3 in the form x plus iy, where x and y are in terms of p. Okay, how do we get x and y in terms of p? So z3 equals z1 divided by z2, right? So can you substitute z1 is p plus 5y divided by 9 plus 8i. So how do we make it into a complex form of x plus iy? We have to multiply with the, because we need to remove the imaginary part from the denominator. How do we do that? We multiply up and down with 9 minus 8i. Okay, so how does that work? Let's multiply out. P into 9 is 9p, p into minus 8i is minus 8pi, 5i into 9 is 45i, 5i into 8i is minus 40i square. Are you with me? At the denominator, we have 9 plus 8i, 9 minus 8i. This is, you could open it manually, or else is difference of two squares. A plus b, a minus b is directly a square, which is 9 square, minus b square, which is 8 square I square. Are you with me? Shortcut of opening a square minus b square plus b, a minus b is a square minus b square. Or else you could manually open and the items will cancel out. Okay, then what do I get here? 9p, you can see 40i square, you know, it's minus 1, right? So this is going to be plus 40 and plus 9p. I'll bring the real terms together. 9p plus 40. Is it okay if I write them together here? Minus 8pi plus 45. So I'll write here plus 45 minus 8p times whole thing bracket I. Can you understand what I did here? I just took the I out and I wrote the remaining terms here. Okay, 45 minus 8p bracket I. And in the denominator, I have 8 square, 9 square is 81. You know, again, I square is minus 1. Minus 1 into minus 8 square is, how much is it? This is a plus 64, right? I square is minus 1 into this minus is plus 8 square is 64. Okay, can I have the addition here? Let's separate the real and imaginary. 9p over 40. 81 plus 64 is 145. Can you see I'm separating? I'm splitting this into 2. 45 minus 8pi divide by 145. So I'm just dividing this or taking it as the real coefficient over denominator plus the imaginary part over the denominator. So splitting it. Okay, is this clear? So this is the answer for part A. Okay, so in the form x plus iy. So clearly it has to be seen in the x plus iy format where you show the real part and the imaginary part separately. Like this. You have to separate it out. You should not leave your answer in this form in this format. Your last answer has to look like this, where real and imaginary are very clearly separated. Okay, so if you leave an answer in this form, you will not get the full mark. Okay, x plus iy should clearly be separated. Okay, so this is the final answer format and it needs to look like that. Okay, next one, determine the exact value of the modulus of Z2. Okay, how do we get the modulus of Z2? So Z2 is 9 plus 8i. So modulus Z2 is 9 square plus 8 square square root. You know, you take the coordinates x square and y square and you square root. So how much is the answer? Root 145. That's the simplest answer. Yes. Okay, moving on to part C. Given that the argument of Z1 is 5 over 3 determine the exact value of P. Okay, so it's the argument of Z1. Okay, how do we normally get the argument? So the argument, now Z1 is given as P plus 5y, right? Okay, so they tell you if the argument of Z1 is 5 over 3. So how do we draw the argument normally? Argument is the angle you make with the positive x-axis, isn't it? So here they tell you the argument is 5 over 3. So the angle you make with the positive x-axis is 5 over 3. Are you with me? So which means you realize that now here P is an unknown. So we do not know whether P is a positive figure or negative, right? P is just a real constant. It could be positive, it could be negative. But they say here, since your argument is 5 over 3, do you see that 5 over 3 means it's the angle you make with the positive x-axis. So it should come over here, right? Are you with me? So then this one should be P. So P should be on the positive x-axis and this one P plus 5y. So value 5 should be the value on the imaginary axis. Are you with me? So how do we get the value of P easily? Yeah, we can use tan theta, right? Tan pi over 3 is opposite over adjacent. Who is the opposite? Who is the opposite? 5. The opposite distance is 5 here. Adjacent is P. Do you agree with me? Okay, so I drew this line by looking at the arguments. Then I place the xy values accordingly. And now we can get the answer. So P equals 5 over tan pi by 3, isn't it? So making sure your calculator is in radian mode, type it down. 5 divided by tan pi over 3 is how much? 5 divided by 5 root 3 over 3. Right, tan pi over 3 is root 3. Anyway, when it rationalizes, when you type in the calculator, the answer will immediately come. Do you agree with me? Are there questions? Okay, so P is 5 root 3 over 3. Roman number 2, determine the exact value of the modulus of Z3. Okay, so you have to get the exact value of the modulus of Z3. How do I get the exact value of modulus of Z3? So we already have the Z3 value here, right? Z3 is 9p plus 40 over 145 plus 45 minus 8p times I over 145. Are you with me? This was our Z3 value, right? Are you with me? Okay, so then we could replace the p value with 5 root 3 over 3 here. Okay, we could replace the p value with 5 root 3 over 3. And then we can try to get the, we can get the modulus. So let's get it. Nine times 5 root 3 over 3 plus 40 over 145. Can you see what I'm doing here? 45 minus 8 times 5 root 3 over 3 divided by 145. This is your I coefficient. Are you with me? So then how do we get the modulus of Z3? Do they want the exact answer? Or demand the exact modulus? Okay, so in that case, shall we simplify this before taking the modulus? Can I know how much is this value here? Okay, so I typed in the cal 9 into 5 root 3 over 3 plus 40, which gives me 40 plus 15 root 3. And don't forget the division by 145, okay? 40 plus 15 root 3 over 145. Is that okay? So I typed the just the numerator. Okay, so let's type the other part also. Okay, so next I type the numerator 45 minus 8 into 5 root 3 over 3. So this gives me the numerator 135 minus 40 root 3 over 3, which means this 3 goes down to the numerator with 145. Okay, or else we could give this entire bracket in this manner. Divide by 145. Let's see if it gives us a, so it directly gives us. Can you see the third form answer? 27 minus 8 root 3. 27 minus 8 root 3 over 87. So this is the I and J. So these are Z3. Now let's get the modulus. So you square 40 plus 15 root 3 over 145. And you square 27 minus 8 root 3 over 87, right? And then you take the square root of it. Are you with me? So let's type each part separately. Here they do not tell us that there's no restriction on using the calculator, right? So there's no problem. So we will don't type the entire thing at once. We'll type section by section. Okay, so here 40 plus 15 root 3 over 145. So I'll be squaring the whole thing and I get, okay, so that will not work. So in that case, we will not give the numerator. 40 plus 15 root 3 square. Okay, so then we do not get a decimal. So we'll have to go, okay, we'll try to do manually here. Or else we can simplify this slightly, right? 40 plus 15 root 3 over 145 can be simplified, isn't it? Yeah, wait, let's simplify that. We can divide the entire thing with a 5. 40 plus 15 root 3 over 145. First, we'll get the simplest answer here. Yeah, so this gives us 8 plus 3 root 3 over 29 because it will divide with a factor of 5, isn't it? All of them, shall I fix this here before going here? So this gives me 8 plus 3 root 3 over 29. Are you with me? Okay, so I fixed the value here, 8 plus 3 root 3 over 29 whole thing square, and then 27 minus 8 root 3 over 87 whole thing square. As you can see, I have given the entire expression in the cal, and then I get the exact answer here. Okay, so this is the squaring part. I get 20 over 87 inside the root because I did not give this root function, right? So 20 over 87, getting the entire root of it. Okay, because in the, you can see I have not given the square root function in the calculator, as you can see. And then square root of my answer, and I get 2 root 435 over 87. 2 root 435 over 87. So actually, this is a little bit of the longer method. Actually, there is a slightly better method of doing this. The easier method of doing this is now they ask you to get the exact value of the modulus of Z3, right? So now what do we know about Z3? The alternative method. We know Z3 is Z1 over Z2. Are you with me? So if you want to find the modulus of Z3, it means you have to get the modulus of Z1 over Z2, right? Which means, okay. So which means you can take the individual modulus of Z1 divided by individual modulus of Z2. Okay, so in the other method, we know the modulus of Z3 is modulus Z1 over Z2 entirely, and then we can break it up as modulus Z1 over modulus Z2. Right, so this is a rule that you learn in your F1 book. When you have a division, a modulus over an entire division, you can break it up as the individual modulus of Z1 divided by the individual modulus of Z2. So I think the individual modulus of Z2 is found. You can see the individual modulus, exact value of the modulus of Z2 is found in part B. So you just have to find the modulus of Z1. Okay, so P value is found, right? What was the P value we found? P is 5 root 3 over 3. So right, tell me what is Z1? Z1 was P plus 5y. Am I correct? Z1 is P plus 5y. Okay, so P value is 5 root 3 over 3. 5 root 3 over 3 plus 5y. Do you agree with me? Now, how do I get the modulus of Z1? 5 root 3 over 3 square plus 5 square. And then you square root. Can I know the answer here? Let's get the individual modulus here. 5 root 3 over 3 square. 5 root 3 over 3 square. Plus 5 square. So I get 100 over 3. Square root of that, I get 10 root 3 over 3. This is the modulus of Z1. So now what I need to do here is let's apply the individual values here. Modulus Z1 is 10 root 3 over 3. Divide by modulus Z2 is the answer we found in part B. Modulus Z2 is root 145. So now let's type everything in the calculator. So 10 root 3 over 3 is already there, divided by root 145. Okay, so I answer is stored in the calculator and root 3 over 3 divided by root 145. And I get 2 root 435 over 87, which is the exact same answer that we got in the earlier part. Now you can see when you compare the two methods, this is the most easiest method. As you can see, this method is really easy. Okay. So I think I would prefer to go with this method. This is more preferable. This taking the modulus of Z3 by taking the modulus of Z1 over Z2 and taking the individual modulus of Z1 divided by the individual modulus of Z2 is it's a lot. You can see the amount of steps and the amount of working has reduced. Okay, so definitely go with this technique rather than going with this one. So this is the best way to go. Okay, so I would like cut this out. This is the best way to go. Okay. Question number 5. So they have given you here fx is equal x to the power 4 minus 12x to the power 302 plus 7 and x values are positive greater than or equal 0. Show that the equation fx equals 0 has a root alpha in the interval 2, 3. Okay, how do we show that there is a root? So what is the general procedure? So you substitute f of 2, get the answer, and substitute f of 3 and get the answer. Okay. So then we get here 2 to the power 4, 12 times 2 to the power 3 over 2 plus 7. Can I know the answer for f of 2? Minus 10.9411255. Okay. And then f3 is 3 to the power 4 minus 12 times 3 to the power 3 over 2. Plus 7. How much is the answer? 25.64617. Okay. So something like this. Now, what do we clearly see? We can see there is a sign change. So you can say there is a sign change. And then normally sign change, and you also need to mention to be for there to be a root, your graph must be continuous, meaning there shouldn't be any asymptotes. Your graph shouldn't be broken. Now, in this case, do you think there are any asymptotes here? Asymptotes are if you have an x value in the denominator, then you can there might be an asymptote. But here, this is definitely a continuous graph. So you can say there is a sign change, and fx is continuous. So make sure you mention all of these things. So it's a sign change and fx is continuous. Therefore, root alpha exists in the interval 2, 3. So in this interval, you definitely have a root because there is a sign change, and because the graph is continuous. By continuous, again, since you asked the question, it means that there are no asymptotes. Now, for example, in graphs where you have x in the denominator, and when there's any x value that can make the denominator 0, that creates an asymptote. So here we don't have such a problem. Okay. So I'll move on to part B. Taking 2.5 as a first approximation to alpha, apply the Newton Raphson procedure once to fx to find a second approximation to alpha, giving your answer 2 dp. Okay, so tell me the Newton Raphson procedure, the equation. What is the equation? Xn plus 1 equals xn minus fxn over f dash xn. Okay, so to get Newton Raphson procedure, you need to get your f dash x also, right? Okay, so we know our fx. Can you all tell me what is the f dash x? Let's differentiate the fx function. F dash x is 4x cubed minus 12 into 3 over 2 x to the power 3 over 2 minus 1 is half. 7 differentiation is 0. So 4x cubed minus 18 x to the power half. So this is f dash x. Okay, so now it's time to substitute the values into the equation. So the first approximation is x naught, right? So they have told you x naught. The first approximation is 2.5. You are supposed to find x1. So how does x1 work? Into this equation, if you replace n with 0, you get x naught plus 1 equals x naught minus fx naught over f dash x naught. Are you with me? Okay, so now what you need to do is x naught is 2.5. Go to your equation, fx equals this equation, type it in the cal and replace the x value with 2.5. Okay, so you can directly do it. Type the equation in the cal Give x as 2.5. What is the answer when you give x as 2.5 here? Minus 1.37166. Take a few extra. We need to give 2 dp. Yeah. Oh, yeah. 4903 divide by f dash x naught. So f dash x naught means you go to your f dash x equation and replace the x with 2.5. So 4 into 2.5 cube minus 18 into 2.5 to the power half. How much is the answer? 34.0395010106. Okay, type this. So the final answer 2.54 when you correct it to 2 decimal places, because they asked you to give your answer 2 dp. So x1 is the second approximation. So this is the second approximation, or you could say alpha. This is your alpha to 2 dp. Okay, so moving to part C, show that your answer to B gives alpha correct to 2 decimal places. How do I show that the answer to part B is giving me alpha correct to 2 dp? So what do we do? If you want to show that your root is correct to 2 dp, you must get the, what should you do here? You must take the upper bound and lower bound relevant to 2 decimal places. And then substitute that into the equation and show that there is a sign change with respect to that interval. Now you are the one who is going to decide the interval. Okay, so they say you to give to show that your answer to part B gives alpha correct to 2 dp. So now you have your alpha written correct to 2 dp here. So in order to show that this alpha value is correct to 2 dp, write the relevant upper bound and lower bound that you learned. I mean, you have learned this in your O-level mathematics, right? Where you write the upper bound and lower bound relevant to 2 dp values. Okay, so how do we do this? So 2.54. What is the upper bound for 2 dp? So the third dp, you correct the third dp, put a 0 here and write the upper bound. Upper bound will be 2.545 because this is 40, this becomes 45. Lower bound will be 2.535. Isn't it? So 40, 45 is the upper bound, 35 is the lower bound. It's exact same amount up and down. And now, so this is the interval. In between this interval, if you round off the decimal to 2 dp, you will end up getting this answer. Now substitute this value into the fx equation. So f of 2.545. And f of 2.535. Substitute this to your main equation. Substitute this to the main equation. Tell me the answer. Yeah, so for f of 2.545, you go to this equation, replace x with 2.545. What is the answer you get? 0.2312. The other one, 2.535 minus 0.1374. Okay, so now what do we see here? There is a sign change. Make sure you give the conclusion. There is a sign change. There is a sign change and fx is continuous. There is a sign change and fx is continuous. Therefore, root alpha equals 2.54. Just use the same words that they use. Root alpha equal 2.54, or you can say alpha is correct to 2 dp. Is correct to 2 dp. Okay, is this clear? Okay, so moving on to question number 6. They say the transformation represented by A maps the point R 3p minus 13 comma p minus 4, where p is a constant onto the point R dash 7 minus 2. Determine the value of p. Okay, so how do we determine the value of p? Yes, so what do we do here? What is the normal equation that we use? Question number 6. The transformation represented by A maps the point. Okay, so then now this is the point, the object coordinate, right? So your object coordinate R and the image coordinate is R dash. So how does it map? The normal equation we use in F1 is your transformation matrix. You multiply with what? The object coordinate. Transformation matrix into the object coordinate equals your image coordinate. So you cannot switch the terms. You cannot switch these two matrices. You have to go in this order. So the transformation matrix is represented by A. So A is 2, 1, 3 minus 4 into what's your object coordinate? And the object coordinate is 3p minus, and does it mean 3p minus 13? Does it mean that there are two values? 3p minus 13 is a single value. 3p minus 13 and the other one is p minus 4 is equal to your image coordinates are what? 7 minus 2. So when I'm writing the coordinates, I'm writing it using a column vector. Because that's how you should write the coordinates. Okay, now, so bear in mind the transformation matrix is a 2 by 2 matrix, 2 rows, 2 columns. However, your object coordinate is what? There are 2 rows and only how many columns? 2 rows and 1 column. Okay, is this clear? So when you multiply 2 by 2 with 2 by 1, you will end up getting a 2 by 1 matrix. So this is a case where you cannot use the calculator to do the multiplication. You must do the multiplication of the matrices manually. So what kind of a matrix am I going to get? 2 by 2 into 2 by 1 will give us what? A 2 by 1 matrix, isn't it? A 2 by 1 matrix where there are 2 rows and only 1 column. Do you agree with me? Which means 2 rows and 1 column means there are only how many elements? You will only have 2 elements. Are you with me? Okay, and then what's the rule of multiplying? Rows are taken from the first matrix, columns are taken from the second matrix. Shall we multiply? So the first element is made by multiplying row 1 with column 1. Are you with me? Okay, so row 1, let's multiply with column 1. What do we get? Shall I write it like this? Row 1, you have to multiply with column 1. This is for the first element. The second element is taken by multiplying row 2 with column 1. So row 2, you don't need to do all of this. With column 1. So this is the matrix. Okay, you don't need to write this. This is actually not necessary. This is if you are a newcomer. So otherwise, if you are quite used to the multiplication, you can go through it immediately. So when you multiply, what happens here? 2 into 3p minus 13 gives you how much? 6p minus 26. And then 3 into 3p minus 4 is 3p minus 12. So this is the entire first element entirely. You have to add everything. And then the second one, 1 into 3p minus 13 is 3p minus 13. Minus 4 into p minus 4 is minus 4p plus 16. So simplify how much, what do we get here? 6p plus 3p is 9p minus 26 minus 12 is minus 38. 3p minus 4p is minus p, minus 13 plus 16 is plus 3. So this is the image coordinate now that you get. So the image coordinate is actually equal to what? So this multiplication is equal to 7 minus 2. So this is equal to 7 minus 2. Are you with me? So now you can use one of these, any one of these two lines to get the p value. So you could say 9p minus 38 equals 7. How much is 9p? 38 plus 7 is? It's 45. 45 divided by 9, p equals 5. Or else if you use the other one, do you think you'll get a different answer? Minus p plus 3 equals minus 2, p equals to 5. Same answer. Do you agree with me? Okay, so p answer is equal to 5. Okay. Next one. The next one, they say the point S has coordinate 0, 7. Given that O is the origin, determine the area of triangle ORS. Okay, how do we get the area of triangle ORS? So I think it's better we draw a quick sketch here, part B. Okay. So draw a quick sketch here. So what do we get? The point O is 0, 0. Point R is ORS. So R value we will have to, we just found the P value as 5, right? So can you all tell me what's the R coordinate when P is 5? Replace P with 5. What is the coordinate of R? 3 into 5 minus 13 is? And 5 minus 4. So R coordinate will be 5, 15 minus 13, 2, 5 minus 4, 1. So R coordinate is 2, 1. Are you with me? R is 2, 1, and then ORS is 0, 7. So when X is 0, Y is 7, which means it's somewhere over here. Are you with me? So this is O, this is R, S. So can't you get the area of this particular triangle? ORS. So it's quite easy to get the area, right? So half into base into height. What is the area? Half into what is the base? Base is the y-axis length, right? So 7. And height is the this distance over here. How much is the perpendicular height? The x distance at R is 2. Is this clear? So half into 7 into the area is 7 square units. Area is 7 square units. Okay, and then they say part C, the transformation represented by A maps the triangle ORS onto the triangle OR dash S dash. Hence, using your answer to part A, part B, determine the area of triangle OR dash S dash. Okay, how does that work? Now they tell you this transformation is going to map this particular triangle into an image OR dash S dash, and then they are asking you to get to determine the area of that image triangle. So are we going to, now we found the R dash coordinate. Do we really need to find and do this with by using coordinates? No, what's the technique we can use? So for transformations with the areas, what's the equation we use? We have transformation we have the area of object or the area of ORS multiplied by what? No, multiplied with the area of your object, you have to multiply with the modulus of your determinant matrix. The determinant of the, So you have to get the modulus of det A. Okay, so why am I using the modulus? To ensure that the determinant is positive, because areas are supposed to be positive. So modulus of determinant A, and this will give you what? The image area. Object area multiplied by modulus of determinant is equal to the image area. Or in other words, in this case, the image area is what? The area of OR dash S dash. Are you with me? So what is the area of ORS? ORS is 7. Determinant of A, did we find? Okay, no, we have to find determinant of A. Shall we find? So what is the determinant of A? Det A. Yeah, so multiply along the main diagonal first, right? 2 into minus 4, then subtract with 1 into 3. Right? 2 into first you have to multiply the main diagonal. 2 into minus 4, minus 8, minus with the other diagonal is 1 into 3, which is 3. How much is the answer? Minus 11. So now let's substitute area of triangle ORS is known, which is 7 into modulus of determinant A is minus 11 equals to the area of the image OR dash S dash. So modulus of negative 11 is positive. So 7 times 11, which means your area is 77. So this is the area of OR dash S dash. Is this clear? Question number 7, the equation 3x square plus px minus 5 equals 0, where p is a constant, has roots alpha and beta. Determine the value of alpha beta. Okay, so how do we get the value of alpha beta? Normally, when it comes to an equation like this, 3x square plus px minus 5. So we have the two equations we write as alpha plus beta and alpha beta. So alpha plus beta, we say it's minus b over a. Alpha beta is c over a. So what is the c value here? Minus 5 over a is 3, because ax square plus bx plus c. A is 3, b is p, c is minus 5. So alpha beta is c over a. C is a negative 5. C is a negative 5. Divided by a is 3. Okay, so alpha beta is minus 5 over 3. The answer for Roman number 1. Roman number 2. How does that work? You have to open up alpha plus 1 over beta into beta plus 1 over alpha. So let's open the bracket. Expand alpha beta. Alpha into 1 over, so alpha into 1 over alpha is 1. Do you agree with me? Alpha multiplied with 1 over alpha is 1. Next one, 1 over beta multiplied with beta is also 1. The next one, 1 over beta into 1 over alpha is 1 over alpha beta. 1 over beta alpha or alpha beta. So alpha beta value is found, which is minus 5 over 3. 1 plus 1 is the 2 here. Plus 1 over alpha beta is minus 5 over 3. Shall I write on top? Because it's 1 over alpha beta is the reciprocal of minus 5 over 3. So it's 3 over minus 5. Or minus 3 over 5 is also okay. Can you type all of this in the cal? How much is the answer? Minus 4 over 15. Is that okay? This is the answer for Roman number 2. Then moving on to part B. Obtain an expression in terms of P for alpha plus beta. So how do we get an expression for alpha plus beta? Alpha plus beta is minus B over A. So what is the B value? Minus P over A is 3. Are you with me? Okay, so alpha plus beta is minus P over 3. Okay, then Roman number 2. You have to add alpha plus 1 over beta with beta plus 1 over alpha. How much is the answer? So first you have to separate them out, right? So you can see in the middle you have a plus sign. Do we need to expand the brackets? No, the brackets are already in the simplest form. Just rearrange. So alpha, I'll bring the beta near the alpha. Alpha plus beta. This guy becomes 1 over beta plus 1 over alpha. Are you with me? The brackets outside are, there's nothing outside the bracket, so you don't have to do it. There's nothing to expand. Okay, so just rearrange one alpha plus beta. I will keep it separate because already we have alpha plus beta there and we know the answer for alpha plus beta. For this guy, I will take the common denominator with what? Alpha beta. So when you take alpha beta here, there's beta. What's missing? Alpha. So you multiply here with alpha plus here you have alpha. You are missing with the beta coefficient here. So then you have 1 times beta. Are you with me? So now everything is in terms of what we know. Alpha plus beta value is known. Alpha beta value is also known. Let's substitute. Alpha plus beta is minus P over 3. Are you with me? Again, alpha plus beta is minus P over 3. Divide by alpha beta is minus 5 over 3. Simplify minus P over 3. Then here minus divided by minus is a plus. And here you get P over 3 into 3 over 5. Are you with me? This 3 goes on top. Actually, the 3 to 3 will cancel out. You could do it immediately without going through for the extra steps here. So I am writing a few extra steps here. Minus P over 3 plus P over 5. Are you with me? How much is the final answer? So you type in the cal minus 1 over 3 plus 1 over 5. And then give the answer in terms of P. How much is it? Minus 2p over 15, minus 2 over 15, and then don't forget the coefficient p. Is this okay? Is this clear? And then moving on to the next part, they say given that alpha plus 1 over beta plus beta plus 1 over alpha is equal to 2 times alpha plus 1 over beta into beta plus 1 over alpha, determine the value of p. So actually we have found the answers for all of these sections, right? Right? Alpha plus 1 over beta, when you add with beta plus 1 over alpha, the answer is equal to 2 times alpha plus 1 over beta into beta plus 1 over alpha. Now, you can see alpha plus 1 over beta, adding with the sum of alpha plus 1 over beta with beta plus 1 over alpha is found in part B, Roman number 2. What was the answer we got? Minus 2p over 15. Shall we replace this as minus 2p over 15? This is equal to 2 times. What about this product? Alpha plus 1 over beta into beta plus 1 over alpha is found in part A, Roman number 2. Minus 4 over 15. Are you with me? So both sides you get a negative. You just need to make P the subject. 8 over 15 into 15 over 2. So you get here what? P equals to 4. So your P value here equals to 4. Is this clear? Part D. Using the value of P found in part C, obtain a quadratic equation with integer coefficient that has roots alpha plus 1 over beta and beta plus 1 over alpha. Okay, normally how do we get this quadratic equation with the roots? What's the main equation that we use to get the quadratic equation? We say x square minus sum of root times x plus product of roots must be equal to 0. So all you need to do is to get the sum of your roots and product of your roots. So what's the sum of roots? Add alpha plus 1 over beta and beta plus 1 over alpha. Do we have this answer already? Yes, alpha plus 1 over beta and beta plus 1 over alpha is minus 2p over 15. P value is found as 4. Replace p as 4. How much is it? Minus 8 over 15. Do you agree? Okay, so then I got the sum of roots. I also get the product of roots. What's the product of roots? Alpha plus 1 over beta multiplied with beta plus 1 over alpha. Don't we have this answer already? Answer for part A, Roman number 2, minus 4 over 15. Okay, so now it's time to substitute and get the quadratic equation. So x square minus sum of roots is minus 8 over 15 times x. Substitute the values into this equation, okay? Plus product of roots is minus 4 over 15 equals to 0. So x square plus 8 over 15 times x minus 4 over 15. Now, is this supposed to be our final answer? They tell you to find the equation or quadratic equation with what? Integer coefficients. So integer coefficients is you multiply the entire equation everyone by 15. So you get here 15x square plus 8x minus 4 equals to 0. Is this clear? Question number 8. A rectangular hyperbola H has Cartesian equation xy equals 16. The point P 40, 4 over t, where t is not equal to 0, lies on the hyperbola. H is the hyperbola. Use calculus to show that the equation of the normal to hyperbola at P is this. Okay. How do we get the equation of the normal? Basically, the first thing to do here is what? Get your equation, differentiate and get the dy by dx, which gives the gradient of the tangent. So first I'll make y the subject. So y equals 16 over x, which gives me y equals 16 times x to the power minus 1. And so for people who have done P3, P4, you could even differentiate this by using product rule. Okay, so any of those methods will work. Okay, so I will go with the basic differentiation method here. So dy by dx gives me minus 16 x to the power minus 2. Do you agree? Substitute the x value and you get the gradient of the tangent. The x value here is 40. So replace x with 40. Shall I first rearrange? Minus 16 x to the power minus 2 is it's x square in the denominator, right? So minus 16 divided by x value here is 40. So 40 square. What do we get? Minus 16 divided by 16t square, which gives me minus 1 over t square. Do you agree? Okay, and then gradient of normal, since we are finding the equation of the normal, gradient of normal would be reciprocal and change the sign. 1 over t square becomes t square, negative becomes positive. Gradient product is minus 1. Now let's get the equation of normal. So equation of normal will be y minus y1, gradient x minus x1. So y minus y1 is 4 over t, right? Because you're finding the normal at the point P. Gradient is t square. X minus x1 is 4t. Y minus 4 over t. So this is t square x minus 4t cube. Are you with me? So now we need to simplify. Shall I multiply now? You can see this show that there is no denominator t. So I will multiply the entire equation with t. to remove the denominator. So this gives me y into t is ty, 4 over t into t is 4, t square x into t is t cube x, 4t to the power 4. 4t cube into t is 4t to the power 4. So it's to show that ty, okay, in the show that they've taken the t cube x here and the minus 4 has gone to the other side. So ty minus t cube x equals 4 minus 4t to the power 4. So this is the show that. As you can see, I have written all the steps because it's a show that and it's 5 marks. It's a show that for 5 marks. Show all the steps. Okay, because show that there is a higher chance that you may not receive marks if you have done any careless mistake in the middle of the steps, or if you have skipped any crucial steps, you will not get the full mark. Okay, so then let's go to the next part. There are 6 marks for part B. The point A on the hyperbola has parameter t equals 2. So this point A is a specific point because they have given you the t value, which means you can get the exact coordinate. The normal to hyperbola at A meets the hyperbola again at B. Fine, determine the exact value of the length of AB. Okay, so how do we do this? So point A on the hyperbola has parameter 2. At t equals 2, can we get the coordinate? Point A. Can I know the point A coordinate? At t equals 2, you just have to put the t value into this equation, the coordinate, and you will get the exact specific coordinate. Replace t as 2. What do we get? 4 times 2 is 8. 4 divided by 2 is 2. 8 comma 2. Okay, so then let's get the equation of the normal at A. So to get the equation of normal at A, all you have to do is to replace the t with 2. So you get here 2y, I'm replacing the t with 2. Here t cube x means 2 cube x equals 4 minus 4 into 2 to the power 4. Do you agree? So 2y minus 8x equals 4 minus 4 into 2 to the power 4. Can I directly have this answer here? 4 minus 4 into 2 to the power 4. Minus 60. Okay, and then simplify this equation. I think we can divide the entire equation everyone by 2. Can be simplified. So divide everyone by 2. And I get here y minus 4x equals minus 30. Okay, so this is the equation of the tangent at the point A. Sorry, this is the equation of what? The normal at the point A. Because we found here the equation of the normal. We replace the t value with 2. And we are getting the equation of the normal at point A. Now they say this equation, the normal at point A means what? It meets the hyperbola. Now you need to have an idea of what's going on. So normally hyperbola looks like this, right? Rectangular hyperbola. So you have this point A. Point A was 8, 2, right? So you draw the normal. Are you with me? This is how the normal looks. So this normal meets the hyperbola again at the point B. Can you see the visual diagram? Point A, and you have the normal at point A meets the hyperbola again at B. How do I get the point B? Because they ask us to get the exact value of the length of AB. So before going for the length of AB, how do I get the point AB? Yeah, so we have to solve the equation of the normal with the equation of the rectangular hyperbola. So solve this with xy equals 16. Shall we make y the subject here? What do I get when I make y the subject? Y equals 4x minus 30. And then substitute this to xy equals 16. Replace here y is 4x minus 30 equals 16. So I get here 4x square minus 30x equals 16. Do you agree? I think we can take everything to one side and also we can divide by 2. Shall I do both of them together? Dividing by 2 and 16, I'll bring it here. Divide by 2, it becomes minus 8. Do you agree? 2x square minus 15x minus 8. Okay, does it factorize? Can I know the two factors? X minus 8, 2x plus 1. Okay. So then we get x equals x minus 8 is 0. Or 2x plus 1 is 0. So x equals 8 or x equals minus half. Do you agree with me? So now which point is corresponding to point B? You know here x equals 8 is corresponding to A. So obviously for B it should be minus half. So replace B with take x value of B as minus half. And you need to get the y coordinate also. Get the y coordinate. How do you get the y coordinate? This is corresponding to A. This should be to B. So y coordinate is we can use xy equals 16, right? So x is minus half into y equals 16. How much is y? Y is minus 32. Okay, so then I have the b coordinate. Who is the b coordinate? Minus half minus 32. Are you with me? Okay, so what was the a coordinate again? It was 8, 2. Now how do I get the length of AB? So how do you get the length between two coordinates? X1 minus x2 square plus y1 minus y2 square holding square root. That's how we do. So here x1, shall I go with a coordinates for x1, y1, b coordinates for x2, y2? So x1 minus x2 square. Be cautious here. There are the minus sign. X1 minus x2 is a minus half. Plus y1, it should be 2 again because we started with this one with a coordinate. For y1 also we have started with a. So 2 minus y1 minus y2 is minus 32 whole thing square. And then square root of the entire thing. Should give me what? Yeah, so 17 root 17 over 2. Do they ask you for an exact answer? Determine the exact area. Yeah, so determine the exact value of the length AB. Yeah, so we have the exact length. 17 root 17 over 2. Is this clear? Then they say the tangent to the hyperbola at A meets the y-axis at the point C. Okay, determine the exact area of triangle ABC. Okay, what do they say again? The tangent to hyperbola at A. Now actually we have the normal to hyperbola at A, right? They wanted to find the tangent to the hyperbola at A meets the y-axis at the point C. So tangent to hyperbola at A would be something like this, right? Can you see? Just touches the point A and goes. So this tangent meets the y-axis at C. You're supposed to get the area of triangle ABC. A, B, and C. Are you with me? Okay, how do I get the area of triangle ABC? Okay, first I think we'll need to get the C coordinates. Shall we get the C coordinates, part C? Okay, so how do I get the coordinates of C? Now, you know, in part A, we already got the gradient of the tangent at point at any point on the curve, isn't it? Do you agree with me? So, or actually, you can take here gradient of the tangent to the curve is minus 1 over t square. Can you see? Are you with me? So, you know, at A, our t value was how much? At A, our t value was 2. So, can't you get the gradient at A? Gradient of the tangent at A is minus 1 over t square. T value is 2 at A, right? At A, the t value is 2. So, minus 1 over 4. The thing is, I need to get the place where the tangent cuts the y-axis. So to get the place where the tangent cuts the y-axis, I should find the equation of the tangent, isn't it? So let's get the equation of the tangent. We don't need to fully simplify. So equation of tangent at A. Y minus y1, gradient x minus x1. What's the x1, y1? So y1, x1, y1 is the A coordinate. So y1 is 2, the y coordinate of A. Gradient is minus 1 over 4, x minus x1 is 8. Now, do they ask us at any point to get the equation of the tangent at A? No, I just need to find the place where this tangent cuts the y-axis. So you don't need to simplify, make y the subject and to try to make this beautiful. All you have to do is what? When you cut y-axis, what do you have to set? Set x to 0 in this equation at this point itself, so that you save your time and you save a lot of time. So here x is 0. So y minus 2 equals minus 104 into minus 8 is plus 2, which gives you y equals 4. Do you agree with me? So then I have the coordinates of C. What's the C coordinate? X is 0, y is 4. Okay, now the task is not to just get the C coordinate, but they're asking you to determine the area of triangle ABC. How do I get the area of triangle ABC? How do I get the area of triangle ABC? Half AB sines. Now the thing is, this is a triangle, and you can see here now, this would have been a lot easier if point B was on the y-axis. But it's not, it's over here. So it doesn't work like that. However, you do have one thing that you know about these two lines. This black color line I drew here, this was the tangent at point A, right? And this green color line I drew here is this is the normal at point A, isn't it? So you know very well normal and tangent are perpendicular. My diagram might look a little off, but a tangent and a normal are definitely perpendicular to each other. So which means we can go for half into base into height. All you need to do is to find the length of what? Who is the base and height? The base and height are adjacent to the right angle, AB and AC. Didn't we already find the length of AB? We have. So that means we have the help of the previous parts, which means we are going in the right track. Okay, when you can use the help of previous part for a last question, it means it helps you to reduce the amount of working. Okay, so then the only thing we have to find here is what? The AC distance. So how do you find the AC distance? We already know the coordinates of C also, right? C was 0, 4. Can't you get the AC distance? Get the AC distance. AC distance again, x1 minus x2 square. So 8 minus 0 square. X1 minus x2 square. Y1. So I will again start with a 2 minus 4 square. Holding square root. How much is it? AC is 2 roots. Can I simplify? 2 root 17. Yes, root 68. Okay, so now we have the length of AC and we have the length of AB. I hope all of you are clear that because of the right angle, AC and AB are the base and height of this right angle triangle. Do you understand? Okay, so because of this right angle triangle at this point, AC and AB are the base and height because base and height are adjacent to the right angle. So how do we get the area then? Area equals half into the AB length into the AC length. So half into what is AB? AB length we found, right? How much? 17 root 17 over 2. AC is 2 root 17. Multiply, get me the exact answer. They do want the exact area, right? Yes. 289 over 2. So this is the exact area of 144.5. The exact area. Is this clear? Question number 9. Fn equals 7 to the power n times 3n plus 1 minus 1. Prove by induction for n is an element of positive integers. Fn is a multiple of 9. Okay, how do we show that something? What is the first step we do in proof by induction? First, we have to prove Fn is a multiple of 9 when n equals 1. You have to show that it works for the very first integer, right? Okay, so how does that work? F of 1. Substitute 7 to the power into 3 times 1 plus 1 minus 1. Can you all simplify here? 7 into 3 times 1 is 3. 3 plus 1 is 4 minus 1. How much is it? 7 times 4, 28. 28 minus 1 is 27. So 27 is a multiple of 9, right? So if 27 is a multiple of 9, it means the result is true for n equals 1, right? Then what do we do? In the next step we assume, right? Assume Fn is divisible by, it is divisible by 9. When what? When n equals k, or you can say when n equals k, assume Fk is divisible by 9. Fk, we'll say Fk is divisible by 9 when n equals k. That's how you create fk. So then what is fk? F of k is, you write the equation, it's 7 to the power k times 3k plus 1 minus 1. Do you agree with me? So we assume that the fk expression is divisible by 9. And now what do we need to do in the next step? We work manually for f of k plus 1, and we need to show the f of k plus 1, the k plus 1 term is divisible by 9. Meaning we have to generate a 9 for the k plus 1 term and show. Now what's the k plus 1 term? Go and replace 7 to the power. Now replace n with k plus 1. And here 3 into replace n with k plus 1. What do you get? 3 times k plus 1, right? Minus 1. Can you see? 7 to the power k plus 1. And inside here 3, n is replaced by k plus 1. Again, there's another plus 1. Minus 1. Be cautious here. 7 to the power k plus 1. I get here 3k plus 3 plus 1 minus 1. Are you with me? Now, do you think by any chance am I creating any 9 here? Does it look like I can take a 9 out and show that this is easily divisible by 9? No, so we need to work on it. How do we work on it? So before going on this, normally what we do is we take fk plus 1 and we subtract with fk. Before going there, I prefer to have my fk plus 1 term in the same with the same powers of fk. Now fk has 7 to the power k. So shall we also make this 7 to the power k? 7 to the power k plus 1 can be written as 7 to the power k times 7 to the power 1. Okay, shall we go for fk plus 1 minus fk? This is the normal strategy we use in your textbook. Okay, so this is the way you learn in your textbook. This is the strategy they teach you. Fk plus 1 is 7 to the power k times 7 to the power 1, 3k plus 4 minus 1. So fk plus 1, this is fk plus 1. You have to subtract with fk. What is fk? 7 to the power k times 3k plus 1 minus 1. Are you with me? Simplify. 7 to the power k times, I'll open here, this is 21k, 7 times 4 is 28. Minus 1, do you agree with me? I open the bracket with just with the 7. Here I have minus 7 to the power k times 3k plus 1. Minus into minus is plus 1. Are you with me? The minus 1 plus 1 cancels out. So I end up getting here 7 to the power k times 21k plus 28 minus 7 to the power k times 3k plus 1. Is this clear? Okay, so now we can simplify, take 7 to the power k out and you could simplify the inside here. 7 to the power k is common. 21k plus 28 minus, you do realize what I'm doing here, right? I'm taking the 7 to the power k out from both of them. And you are remaining here with 3k plus 1. Okay, so 7 to the power k, I took it out. So 21k plus 28 minus the 3k plus 1. Simplify, what do we get? 7 to the power k times 21k minus 3k is 18k plus 28. And here this is minus into plus 1 is minus 1. So 28 minus 1 is plus 27. So what do you see now? Clearly we can get a multiple of 9 here. Can you see? So I can take a 9 out. 9 times, I'll take the 9 out. 7 to the power k. What do we get here? 2k plus 3. Can you see? So this is the answer for what? Fk plus 1 minus fk. Now I'm supposed to get the show there for f of k plus 1. So take fk to the other side. 9 into 7 to the power k times 2k plus 3 minus fk goes to the other side as plus fk. Okay, so now what do we have to say about the k plus 1 term? Very clearly you can see this one. There's visibly a 9 to be seen here. And fk, is, after the plus sign, you have the fk. And we know fk, we have assumed that it is divisible by 9, which means this entire expression is divisible by 9. So you can say, if the result is true, so you have to give your conclusion. Make sure you give this conclusion. If the result is true for n equals k, then it is true for n equals k plus 1. And then as the result has been shown to be true for n equals 1, then the result is true for all n element of positive integers. Okay, so this is the part 1. Okay, so moving on to part B. They say a sequence of numbers, Roman number 2, right? So moving on to Roman number 2 in question number 9. A sequence of numbers is defined by u1 equals 2, that's the first term, u2 equals 6, that's the second term. Then they have given you a recurrence relationship here. Un plus 2, the n plus 2 term is equal to 3 times un plus 1 minus 2 times un. So you can see here to get the a certain term, you need the previous 2 terms. Can you see? That's why un plus 1 is a term behind n plus 2 and un is a term 2 terms behind n plus 2. Okay, so in this recurrence relationship, you to get the next term, you need the previous 2 terms. Okay, anyway, now they are asking you to do what? Prove by induction that for n and being an element of a positive integer, the nth term is given by the un is equal to 2 times 2 to the power n minus 1. So you have to prove that this equation, the terms you get, the u1, u2, u3, u4, the terms you get from this person will be the same as the terms you get from this person. The recurrence relation, because you realize in the recurrence relation, you cannot jump terms. Can you immediately find u10 from the recurrence relationship? No, to find terms in a recurrence relationship, you have to go in order. You have to know u3 to find u4. To find u5, you must know the u4 value. So you must know the previous term. In this case, you must know the previous two terms to get the next term. Okay, so otherwise you cannot proceed. You just cannot find a term in the middle. But over here, you can see that this is the proof we are trying to do. So we are trying to say that this person, now here you can see you can find u5 or the 10th term. You can find it immediately. So we are trying to show that this will give the correct answer for our recurrence formula. We are trying to say that whatever the answers that we get from this will surely correspond with the answers we get from the recurrence formula. Okay, so then how do we start this? The first thing we have to do is we have to check whether this is working for the very first term. If it doesn't work for the very first term, so we'll check here. So I will check both sides. The recurrence relation, you have to check it against the okay, so you have to check it against this the result. Okay, so this is the general statement, or in the textbook we use general statement or the general formula. Okay, so this is the general statement or the general formula. Okay, so in the recurrence relation, what's u1? First term is 2. They have given here. Actually, it's given to you. First term is given. So then let's check whether our general statement also will give the same answer, because it has to. If it doesn't, then this is not true, right? So let's check whether it works. u1 equals 2 into 2 to the power 1 minus 1. How much is it? 2 into 2 minus 1 is 1. So 2 into 1 is 2. So as you can see, the recurrence relation answer and the general statement answer matches. Do we stop from there? No. So you can see they have also given the second term. So check the second term. u2 is 6. Get the second term from the general statement. From the general statement, u2 is 2 times 2 to the power 2 minus 1. 2 to the power 2 is 4. 4 minus 1 is 3. 3 times 2 is 6. The exact same answer. Now, do we stop from here? Normally, because you can see I didn't get to use the recurrence relation even once, right? In the textbook, so they tell you that once you now, because u1, u2 is given, you should at least try to find one term from the recurrence relation. Okay, so how do we get the next term from the recurrence relation? I had to find the third term, u3. How do I get u3? u3 equals what? 3 u2, right? Do you realize I get u3 when I use n as 1 here? So when I use n as 1, u3, 1 plus 2 is the third term. u3 equals 3 times u1 plus 1, that's u2, minus 2 times u1. Do you realize what's going on here? So I'm now going to use the general, the recurrence relationship at least once to get the, to calculate the third term. Okay, so the second term is known. Second term is 6 minus 2 times first term is 2. 3 times 6 is 18 minus 2 times 2 is 4. How much is it? 18 minus 4 is 14. Okay, let's see whether we can get the same answer from the general statement. So I have to get the third term from the general statement. How do I get the third term? U3 equals 2 times 2 to the power 3 minus 1. Because to get the third term directly, you have to use n as 3 here. Okay, I just need to match the terms. The third term from here and I need to check the third term here. So 2 times 2 to the power 3 is 8. 8 minus 1 is 7. 7 times 2 is 14. So as you can see, the general statement and recurrence relation is, they completely match. Can you see? Okay, so you can say, so the result is true for n equals 1, 2 and 3. Okay, so then the next one, what do? We assume, what do? We assume, yes, we assume for n equals k, right? We assume for n equals k, what is it? uk equals the kth term, 2 times 2 to the power k minus 1. We assume this to be true. So we assume for n equals k that the kth term we get from the recurrence formula will be equal to the kth term we get from the general statement. So the kth term is equal to 2 times 2 to the power k minus 1. So assume for n equals k, that's not the only assumption here. In these kinds of questions where you have a recurrence relationship where you depend on the two previous term, you do an assumption not just for one, you do an assumption for 2%. For assume for n equals k and n equals k plus 1, because the recurrence formula is made up of two previous terms, not just one term. So you assume for both of them, the k term and the k plus 1th term. So uk plus 1 is what? Go here, replace n with k. So we are assuming the k plus 1th term of the recurrence also is equal to the k plus 1th term of the general. So this is equal to 2 times 2 to the power k plus 1 minus 1. So these are the two assumptions that we are going to use here. Okay, and now what do? Now we are going to get the next term. Who is the next term? The k plus 2 term. We are going to get the k plus 2 term from the recurrence formula. And we have to show that the k plus 2 term from the recurrence formula will match the k plus 2 term from the general statement. What's the k plus 2 term in the general statement? 2 times 2 to the power k plus 2 minus 1, right? So this is the target. This is what we need to achieve. So then we need to see whether we can get the k plus 2 term from the recurrence formula. So from the recurrence formula, let's get the k plus 2 term. So from our recurrence formula, what do we get? Right, the k plus 2 term is equal to what? From the recurrence formula, u k plus 2 will be equal to what? You can see here n is directly k, right? Equals 3 times u to the power u, the k plus 1 term, 3 times u k plus 1 minus 2 times u k, right? Do you agree with me? So I'm doing this from the recurrence formula. This is from the recurrence relation. From the recurrence relation, I'm writing the k plus 2 term. K plus 2 term is equal to 3 times uk plus 1 minus 2 times uk. Okay, now what do we know about the k plus 1 term and the kth term? K plus 1 term and the kth term we have already assumed. We have already found. We have already said that whatever we get, that those two terms we got from the general statement is true. That's our assumption. So now let's simplify. Let's substitute. 3 times uk plus 1 is 2 into 2 to the power k plus 1 minus 1. Do you agree? Minus 2 times uk is 2 into 2 to the power k minus 1. Are you with me? Okay, so now we have to simplify this. To simplify, and what's the task? What's the target? Your target is to say that the k plus 2 term from the recurrence will be the k plus 2 from the general. So you have to get this show that 2 times 2 to the power k plus 2 minus 1. This is the show that. So you need to get that show that over here. Okay, your task is to get 2 times 2 to the power k plus 2 minus 1. So just write it down and keep it somewhere just to know that. So that when you simplify, this is what your end goal should be. Okay, so this is what your end goal should be. So let's work towards that. How do we do that? This is 6 times 2 to the power k plus 1 minus 1. This is 4 times 2 to the power k minus 1. Open here 6 into 2 to the power k. Actually, it's better if we keep it in terms of 2, right? Shall I keep it in terms of 3 times 2? Let's open 3 times 2 to the power k plus 1 minus 3 times 2. Do you agree with me opening brackets in this manner? 3 times 2 with this and 3 times 2 with this. Here, 2 times 2, you open it 2 to the power k. And here, minus will be a plus, right? Plus 2 times 2, you multiply with 1. So now you can see we can get, now I want to create a k plus 2. Can you see how I'm getting the power k plus 2 here? So this is 2 to the power 1. So 3 times the 2 to the power 1 and 2 to the power k plus 1, the power side, and you get 2 to the power k plus 2. Can you see? Here 3 times 2 is 6. In here also 2 to the power 1, 2 to the power 1 along with 2 to the power k gives you 2 to the power k plus 2. Are you with me? Plus 2 times 2 is here. It gives you a 4. So here 3 times 2 to the power k plus 2 minus 2 to the power k plus 2 minus 6 plus 4 is minus 2. Do you agree with me? So when you simplify, what does this represent? This is like a 3x because the k plus 2 is a single term. This is like a 3x minus 1x. Just 2 to the power k plus 3 is like 1x. So 3x minus 1x is how much? It's 2x, right? 3x minus 1x is 2x. So 3 minus 1. So it's 2 times 2 to the power k plus 2 minus 2. And then take the 2 out. 2 to the power k plus 2 minus 1. Can you see? This is the show that. Do you agree? This is what we need to show. Okay, then you can say, therefore, if the result is true for n equals k and n equals k plus 1, then it is true for n equals k plus 2. And then you can say as the result has been shown to be true for what? As the result has been shown to be true for n equals 1, n equals 2 and n equals 3, then the result is true for all n element of positive integers. Are you with me? This is the answer. Okay, is this clear? So this is the end of the Jan 2020 F1 paper. A little bit ahead. Okay, let's get the mass. Mass is 1 over 3 pi r square. What is r square? R is r over 3. 1 over 3 pi r square. H is also h over 3. So when you simplify, what do I get? I get here, this is 1 over, 3 into 3 square into 3 is 81 pi r square h. Do you agree? 1 over 81 pi r square h. Okay, and then the other guy, the center of mass. Now be cautious, the center of mass we are measuring from O. Okay, remember with the center of mass we measure from O. So this remaining distance was 2 over 3h, right? Isn't it? This remaining distance is 2 over 3h. Then from the origin or from the plane face, the center of mass of the cone is 1/4 of its height, right? You remember 3/4 of the height from the vertex, so 1/4 of height from the plane face, so 1/4 of this particular height. 1/4 of what is the height here? 1/4 of the height of this cone is 1 over 3h, or h over 3. So remember that gives you the center of mass of distance from the plane face. Is that the distance I want here? No, I want it measured from the origin. So from the origin means I have to add 2 over 3h. Do you agree? Because I'm giving the center of mass from the O here, the 2 over 3h plus the 1/4 of this h, 1/4 of this con's height. Do you agree? Can I know the answer here? Simplified answer. H over 12 plus 2h over 3. How much is it? How much? 3h over 4. Do you agree? Okay, then the last one. Last one is where we remove, right? Last one is where we remove. So can I know the mass difference? Obviously, you have to subtract. 1 over 3 pi r square, you have to subtract with 1 over 81 pi r square. Let me take pi r square out. 1 over 3 minus 1 over 81. How much is it? How much? So 26 over 81 pi r square. And what about the center of mass? So that's what we are trying to find. Okay, so we are ready with the table now. Now it's time to apply, take mass into center of mass and get the answer. So let's multiply. So remember, from the large con, you are removing the small con. I put a minus sign to remind us that we are supposed to remove. From the large con, we remove the small con and we get this frustum shape. Okay. Okay, so let's multiply. How does it work? 1 over 3 pi r square h multiplying with 1 over 4h. Then it's not addition, it's a subtraction. 1 over 81 pi r square h into 3h over 4. Agree? Equals to total mass 26 over 81 pi r square h into x bar. Do you agree? Okay, and then you can cut off the common things. So for everyone, pi r square h is common. Can you see there are 3 terms? Pi r square h is common to everyone. Can I know the answer here? 1 over 3 into 1 over 4 is 1 over 12h minus 1 over 81 into 3 over 4 is 1 over 81 into 3 over 4 is, 1 over 108. H equals 26 over 81 into x bar. Can I know the subtraction? 1 over 12 minus 1 over 108. How much is it? So 2 over 27h. Shall I bring the 26 and 81 to the other side? 81 comes up, 26 comes down. Do you agree? So 2 over 27. Okay, so 2 over 27 into 81 over 26. Do you get the show that? 3 over 13. This is the show that, right? Three over 13h. Agreed? So this is the show that. Okay, let's go. Okay. Okay, so moving on to the last part, they say the solid F rests in equilibrium with its curved surface in contact with the horizontal plane. So this solid F, okay, it rests in equilibrium with its curved surface. Have you seen this? The curved surface, you're keeping it on a horizontal plane. Show that 13r square is less than or equal 17h square for this to be in equilibrium. So I think I might have discussed this in a previous paper as well. I think I gave the, yes, where you learn where when you keep the object where it can turn back again. So let me explain. So I think I gave the theory to you in a previous paper also. Okay, so how does it work? Now you keep this piece, you keep this on the surface, right? So then you, when you keep this curved surface on here, you end up creating something like this, right? So this is what you create, right? Can you see? So then there were very specific requirements to keep this in equilibrium. Okay, so let's draw the axis of symmetry here. So this is the full cone if it were there. Okay, so I drew the axis of symmetry. So they say you that now they keep this solid F in with its curved surface, and they say it's in equilibrium. So if it is in equilibrium, you have to show that this condition is satisfied. Are you with me? Okay, so what is the requirement? Now, right now we found that the center of mass is at a distance 3/13 h from the where? From the larger surface, right? From the larger plane space. Okay. So what is the requirement for this to be in equilibrium? Do you remember me talking to you about this? Now you know if this might, the problem is whether this will turn back, or we require this to stay in equilibrium, not turn back. So do you remember how we mark the forces in this specific question? So at this last end, okay, at this very last end, you mark the normal reaction, isn't it? Are you with me? So you mark this normal reaction here. And the thing is, it's not the normal reaction. It's just that the fact that this is the critical point. So let me name this as point X. So if your center of mass, okay, if your G is after this point, you can see your G can go down and it can meet with this surface, right? So in that case, this object will be in equilibrium. Yes, why? Because when your center of mass is acting over in this area, the weight can go down and it can meet, I mean, the line of action of the weight can meet the surface, which means the normal reaction will act at that point. But what happens if your weight is acting over here after this X? Over here, what if your weight is somewhere over here? So can you see when you mark the weight, can the line of action of the weight meet with the can we have the normal reaction occurring from this point? No, isn't it? It's a normal reaction and the weight component. Now, when there are two forces in equilibrium, you need to realize that those two forces should be on the same line to be in equilibrium. Otherwise, there will be a moment. So that's what happens if you have the center of mass G. If it's over at this point, the normal reaction will come to the very last point, and G over here, it will create a moment, and this will turn front. So it will not be in equilibrium. So in order for this object to be in equilibrium, okay, so this is not the normal reaction. Just I'll draw this dotted line here. Okay, so all that's required here is, okay, all that's required here is this point X. So this point X is the special point here. Okay, the G should be after. Your G should be after point X. Are you with me? In that case, the object will be in equilibrium because the weight and the normal reaction can act on the same line. Because if the G acts like this, then normal reaction will act on the same line upwards like this. They are on the same line. The weight and G can act on the same line. While if the G goes to the other side behind X, the normal reaction and G will not act on the same line. Do you agree? Because normal reaction can only act when there's a touch at that point. Okay, so now what we need to do is to get this, show that. Okay, let me mark this point G here. Okay, so I have to get these distances. Okay, I need to get this distance. How do I do that? How do I do that? Let me mark some extra information here. Okay, so I will name this vertex. This was the vertex V, right? Are you with me? Okay, so this is the vertex V. Did we know the angle of this particular cone? No, right? Okay, so let me, let me take the vertex as V, and now let's write the requirement to be in equilibrium. To be in equilibrium, if you talk about the distances, what is the requirement? The distance VG, can you see V to G distance, should be what? The VG distance should be greater than or equal to the Vx distance. Do you agree with me? It needs to be greater. The V to G distance should be greater than or equal to Vx. It can even be on top of X, but a Vg should be greater than or equal to Vx, so that G will, the weight and normal reaction can act on the same line over here. So this is the requirement to be in equilibrium. And if you can now successfully find the Vg and Vx distances, you should be able to get this, show that. Okay, how do I get these distances? Okay, let me mark this. Now I know that this is, how much was this height? This was, what was the part we removed? We removed 1/3h, right? And this radius was 1/3r. So I'll say this angle is alpha. Okay, I'll say this angle is alpha. Okay, so we don't need to even go with V. We can even mark a point at this at the smaller plane phase and also do it. Okay, so now what? Okay, so this height is 1 over 3h, the cone that you remove. This height is 1 over 3r, right? So we found that the height and radius of the cone that we removed was 1 over 3h and 1 over 3r. Do you agree with me? Okay, let me take this point as C. Shall I name it as C or give some W? Okay, you all want W, right? You said you want to name it W. Just give it any name, okay? Just a letter name because I want to give these distances. So what we need to do here is, okay. Even you can even write to be in equilibrium without going Vg is greater than or equal Vx. You could even write what? The Wx distance can be what? Sorry, the Wg distance should be greater than or equal Wx. Even that is okay because otherwise for Vg I have to get this 1 over 3h also I have to add. Okay, so we can go with Wx, Wg distance must be higher than W2x. That means the center of mass from the smaller plane phase to G, that distance must be higher than this point X. Now point X, how do I mark? This point X is a special point because that I drew this from the very edge of the from the very edge here. The last place where the normal reaction can act. So that is the critical place, and I drew the vertical line over here and I marked this point X on the axis of symmetry. Okay, so now what I want to do is I want to get the WG distance and WX distance. So WG distance is not an issue, right? Because at the other side I marked O and OG distance we found. What was the OG distance? The center of mass was how much? OG distance was, we found it as 3 over 13h. And also we know that this distance is 2 over 3h, right? So is it difficult to get the WG length now? If this is the whole thing is 2 over 3h, this is 3 over 13h. How much is WG? What is the WG length? How do I get that length? From 2 over 3h, I subtract the 3 over 13h. Do you agree? So 2 over 3 minus 3 over 13 is 17 over 39. 17 over 39h. Do you agree? Okay, and then the other one, now I got the WG distance. Now to get WX. So WX is a little bit of a challenge. So let me show you how it's done. Okay, so I think for WX, what I'll do is I will be using the help of the cone that I removed also. Okay, look at how it's done. I made this quite large. So I have marked the angle alpha here, the angle at the vertex of the cone. So do you agree if I write like this? What is tan alpha if you consider this small triangle here? Tan alpha is opposite over adjacent. Do you agree? So opposite is 1 over 3h. 1 over 3r divided by 1 over 3h. How much is it at the end? 1 over 3 cancels. You get r over h. Do you agree? And then also do you see that you have 90 degree here? And this is going to be 90 minus alpha. Which means also do you see that vertical and horizontal here is a 90. Can you see that? So that this horizontal and this vertical is a 90, which means this angle here again is what? This small angle here is again a alpha. Do you see what I'm talking about? This small angle here is again an alpha, this same alpha. Are you with me? Can you understand how I marked the alpha in this small angle here? Because this angle alpha, this is 90 minus alpha, which means this is the horizontal, and I told you this is the vertical, the last place where the normal reaction acts. So these two are making a 90 here, which means if this small angle is 90 minus alpha, the other one has to be alpha. Can you write tan alpha by using this small triangle as well? So you can see you have this small triangle, right angle triangle over here. Can you see? Can you write tan alpha for that triangle as well? How do you write it? Tan alpha equals opposite over adjacent. Opposite is the WX. What we need. We are trying to find WX, right? Opposite over adjacent is what? You can see this is the 90 over here, right? So who is the adjacent here? This is the opposite. This is the 90 here. This is the adjacent. Don't we know this length? 1 over 3r. It's 1 over 3r. I hope you guys can understand what I'm doing here. I use this angle alpha into here to this point. Okay, there's another right angle, the small right angle triangle concerning wx. Okay, so then opposite is wx, adjacent is 1 over 3r. So tan alpha value, now we know it, right? Tan alpha value is r over h. Do you agree with me? And I can find wx now. So tan alpha is r over h equals wx over 1 over 3r. So multiply wx equals r over h into 1 over 3r. So what do you get here? 1 over 3r, I brought it immediately as a multiplication. What do I get? R square over 3h is equal to wx. Do you agree? So wx will be equal to r square over 3h. Children, do you agree? Okay, so I have the wx distance, I have the wg distance. Now it's time to apply it into this. We don't need to go with vg and vx because otherwise you have to add 1 over 3h to both of them again. That's not necessary, right? So wg is 17 over 39h. Do you agree? Is greater than or equal. Wx is r square over 3h. So now cross multiply and let's get the answer. 17h into 3h greater than or equal r square into 39. Are you with me? So 17h into h is h square. I think I can see 39 and 3 I can divide. Shall I divide the 39 and 3? So I get here 17h square greater than or equal 13r square. Is this to show that 13r square is less than or equal 17h square? So that's what I got here, right? Just that the two sides I have written the other side. 13r square has the mouth closed towards it. So here also I have 13r square, mouth is closed towards it. So I could write 13r square, mouth is closed towards it, 17h square, mouth is open towards 17h square. So I have not done any difference. Okay, I really hope you understood this part. I explained this in a previous video as well. This part is a little bit tricky. Okay, but if you can understand how to take the distances, then if you can understand, then you can get the show that's quite easily. Okay. Okay, so this is the end of the October 2021 M3 paper.